Yes. Hello? It's on now. So, our topic is something really exciting. It's unsolved murders. So, who here watches SVU? Yeah? Okay, cool. All right. So, this might be really relevant to your TV watching patterns or whatever. So, next slide, please. All right. So 3 in 10 murders are unsolved in the U.S. A solved murder is called a murder, like the rate of murders being solved is called murder clearance rate. It's a metric that a lot of towns and municipalities like want to increase because of many different reasons, but still many murders remain unsolved. Here, well, so the reason that we might want to solve a murder is because unsolved murders cause future murders. A journalist once said this, take a bunch of teenage boys from the whitest, safest suburb in America and plunk them down in a place where their friends are murdered and they're constantly attacked and threatened. So like the most sheltered people, put them somewhere where their friends are always being threatened, signal that no one cares, and fail to solve murders, limit their options for escape, and then see what happens. So basically the idea is that like if someone has the idea that they could get away with murder and they feel like they don't have any other options, they might commit more murders. It might come to their mind. So it's a little difficult to put a dollar amount on a human life. It can lead to some ethical questions. However, the RAND Corporation, which is a nonprofit that improves policy and decision making, did a little research on this, and they determined that a murder is costs $8.7 million, and that's in the opportunity cost of a victim's estimated societal contributions. So that's a lot of money, and it also has a lot of intangible repercussions. So the safety of a town. So like if you're the mayor of a town, you want your town to be safe. So you don't want murderers running around, as one might. Then the trust in leadership. There's a term called legal cynicism where people in a municipality might say, oh, like our government doesn't care about us, they won't do anything. That's cynicism against the legal system. And then also publicity. If you're known to be an area that's high crime and has a lot of murderers on the loose, that's not great for, that has a lot of like economic repercussions. You might affect like spending or property values or something like that. So the idea is to take a data set of murders that happened over time and try to predict which murders will remain unsolved. So in order to possibly have some sort of intervention and solve more murders. So there are different factors that we found that might make a murder less likely to be solved. So our data set is 690,000 homicide cases from 1976 to present. It's from the Murder Accountability Project, which was a nonprofit that takes data from the FBI and the Freedom of Information Act and formats it so that people can use it for machine learning and even do things like find serial killers. So in the data set, there are a few features. There's information on the actual incident, so each one had a record ID, and an incident ID within that area, within that municipality. The target variable is crime solved, but we switched it to crime unsolved because that is the class of interest. Things like the weapon, the location, the date, And then information on the victim, the perpetrator, and the agency, so the police department or county sheriff department or something like that, that the crime was reported to. All right, so we're focused here on the positives, and we found that there is not that much of a difference between a positive, like a true positive, and a false negative, for instance, because of a few different reasons. But basically, a positive would be if the crime isn't solved, it's a safety threat, it causes bad publicity, and it costs lives of each future victim that a murderer might kill. A true negative, which is the crime being solved, it spares the cost of lives of each future victim. You can't change the past, but you can change the future. And but it also costs the imprisoning of the perpetrator. So prison has a huge cost on society. So so the government does take on that cost. So in the case of, like, for instance, a false positive, though, like, you might say, like why was the murder solved when we didn't think it was going to be solved? Like, did that person, like, know a police officer? Is that person like connected in some way? So that would just be something that we might want to research. And then as far as false negative, the model predicts the murder will be solved, but the murder remains unsolved. Why did that happen? Are we under-resourced? What happened there? Sushant is going to share the next part of this.
Hello, everyone. Yeah, so when we started to build the model, so the first thing that we did was to use all the features. We did some basic cleaning, we did some mean imputing of the missing values, and then we built the model. Honestly, when we first got this data set, we thought we had stumbled on a gold mine and we will get some very good results. But unfortunately, this is the thing that we got. The perfect ROC curve and those two perpendicular lines. So at this point of time, we were actually very disheartened and we thought that we might go to a different data set. But then we went back to the drawing board and we thought, what is the problem? And you see, these are the feature impacts that we got with this model. Perpetrator age, race, relationship, perpetrator ethnicity, perpetrator counts. Okay, so this made us believe that our model had target leakage. And the target leakage was happening because of the perpetrator information in the dataset. Why target leakage? Because our target variable is whether a crime is unsolved or it is solved. If a crime is unsolved, we clearly don't know anything about the perpetrator. And we had lots of data which only pertain to the perpetrator. We again did the remodeling. We again built the models. And this time we removed all the perpetrator information from the data set. Again, we got the same results. The third thing that we did was there was something called relationship in the victim information. If you know the relationship, then you know who is the perpetrator. So the last thing that we did, we removed the relationship information in the data set, and then we got this. So from two perpendicular lines, we got a perfect bow, if that is the correct word. Okay. Yeah. And these were the top features: weapon, city and state, agency name, state, victim age, year. Now, city and state and agency name. So the data set that we had, it had the same agency name as the city. So even though it shows as the top predictor, but city and state and agency name are one and the same thing. Then we tried to visualize these results, and yeah. And recall happens to be the best metric. And this was achieved by light gradient boosting on elastic net predictions. And it gave us a good amount of AUC also. Sensitivity in this case came out to be 0.94. And that was our best model. Yeah. Yeah, so these are the most important features, and Aman will talk about.
So we used as attempt second to find out the top 5 features. So we found like weapon, state, city, and victim age years are the top 5 predictors as per the attempt 2. So when we used tree map to show the average unsolved cases and the number of records, as you can say, and in this visualization, guns are considered differently. For example, firearms, guns, handguns, and the shotguns. These all guns type are considered separately. So we found out that the if a person used firearm and so the unsolved crime case is 48% out of 46,514, followed by the strangulations, gun, fire, and handguns. So these are the top 5 unsolved cases as per the weapon used. If we use state-wise, it is showing from light to dark. That means if the unsolved average is high, so it is showing the dark color. So top 5 states are New York, Illinois, California, Missouri, and Indiana. So we use top 10 cities to plot the average unsold rate. So we found out that the Los Angeles has the highest unsold, followed by New York, Illinois, Wayne, Michigan, Harris, Texas. And this is showing the victim age, which tells us like if the victim age is in between 10 to 30, because it has a more than 50% cases in our data set that the victim age is 10 to 30. And they have the highest unsold rate. And for others, it's the average, like almost the same average for the crime unsold. This is just to see the trend line of the average crime unsold. So we can just see like from 1980 to 2014, we are having the same average for every years.
So similarly to the issue with the health, the hospital, we found it a little bit difficult to have actionable insights here. One thing, like if we were to be like the FBI or something, we could look at location and say, okay, we're going to concentrate on these different locations. Maybe if we're the government, we would give different cities funding to raise their murder clearance rates. If we were to look at weapons, we could require fingerprinting to purchase firearms so that we could easily track who the person was that used the gun, assuming it's the same person that registered the gun. For strangulation, a lot of the times that's serial killer cases, so we could look at the past data and try to find patterns from new murder cases as well. Something interesting that I found was that a lot of the strangulation cases were actually around like undocumented things like sex work. So more advocacy around those types of cases would be good as well. And then you can't do anything with the past, but you can look at like what happened that year. Maybe government funded funds were restricted. Maybe a program was put into place. So like maybe going deeper into what happened in the different years would be helpful. But the victim information itself isn't actionable because you can't change who a person is. You can't change what their age was. You can only maybe put in more effort into certain cases, which has some ethical implications. But not all hope is lost. Boston Police Department actually did raise their murder clearance rate by 10%. They did that by analyzing past data like we're doing here, hiring investigators. I think it was they increased their force of like detectives by a third. Training them on like specific ways to solve these crimes and then equipping them with new tools. So So our lessons learned was that to think about every data point before you start. So like really go through them and like engineer the features. You save a lot of time that way. Not all insights are actionable. Anything involving like who a person is or what their current state is that we can't control as like a police department or a government agency is not actionable. And also don't give up. So does anyone have any questions? David?
Out of curiosity, for the firearms, you guys given information related to where they're registered firearms or unregistered firearms?
No, that they didn't have that data point. What? Why?
Just because a lot of the murders are probably unsolved are because of unregistered firearms.
Yeah.
That black market is. So, assuming if you want to filter out based on assuming the perpetrator information, you could probably figure out who killed someone if they had a registered firearm versus an unregistered firearm. Right?
We didn't get that information.
That's fine. Thank you.
All right.
Thank you.
Any question?
Anyone? Yes.
You feel New York, and I guess the years was a big factor because of, I don't know, corruption.
Oh, that could be it.
I mean, like a big part that stood out was, I think it was 1990s to 2000s was your biggest,
You're referring to this? Yeah.
around that time, still a lot of corruption.
Yeah, actually, if you think about it, if you see from 1980 to 2015, there hasn't been any significant improvement in the unsolved homicides rate. Although there is a slight burp around 1992, but it is roughly 30% in last 25 years, and that is something food for thought. That why in 25 years also we have the same unsolved crime rate.
Yeah, I think that's also a good point of like, even though we're predicting the future, you have to look at the context of the data and what happened at that time. So I think that's a really good point. You look like you have a question.
So I guess my question is like, so you had like a sort of like an outcome at the end and like an application, but is this sort of for solving cold cases or is this for solving future cases? Because I could see it working both ways, but I'm just curious on what it's really aiming to get at here.
Yeah, I think for within the scope of the assignment would be to be solving future cases and look at anything coming in. But there have been people who use this data set to like go back and find patterns with like strangulation in Chicago or something, and then they were able to kind of solve those cold cases as well. So there's a lot you could do with the past data. You can create predictive models, but you could also find those patterns.
All right. Thank you very much.
Thank you.